Welcome to the Virginia Education Center for Asphalt Technology. This is the Asphalt Field Level 2 class, and in this module we're going to talk about density testing. In this first session we're going to talk about that in an overview perspective. Learning objectives for this module are to understand and demonstrate procedures and methods for establishing the roller pattern. We're going to do the same thing for establishing a control strip, and then we're going to do that test sections that we do. And this is in the overview section. You get an opportunity. We're going to go through each one of these independently because there's a method A in the test sections that uses cores, and then there's a method B doing test sections that uses a nuclear density gauge. So density acceptance. VDOT requires that the contractor perform density testing on all surface, intermediate, and base asphalt courses, and those are to determine that they meet the specifications for each job mix that's utilized. As I said earlier, we're going to talk about all the different methods and how each one of those steps is done. Right now we're going to talk about it in an overview. Later on we'll actually go through each one of these steps independently. So in general, all paving requires a certified asphalt field level 2 technician. That's why you're taking the class, so that you can be certified and be that asphalt field level 2 technician in the field on a given project. All the equipment necessary for bulking cores in the field is required to actually be there on site in the field, and a calibrated nuclear gauge for acceptance testing and also for monitoring. We'll talk about that further as we go through this. There are 3 different phases of density testing. Again, in this overview, we're going to capture each one of those steps in an overview perspective. That's going to include the roller pattern, the control strip, and then that QC test section or the lots associated with actually testing as you're actually paving down the roadway. We'll go through each one of those 3, and we'll go through each one of those in detail in subsequent modules. First and foremost, you need to understand where a lot of these requirements come from. Things such as the roller pattern and the control strip. All the details associated with each of those steps is outlined in VTM 76. That's Virginia Test Method 76. You go to that and it'll actually show you exactly how to do all these steps. General density requirements are things such as thin lifts, surface treatments, and weak structures. There's small quantities and patching. There's trench widening. Then there's your standard paving, which we'll spend a fair amount of time talking about test sections on standard paving. But each one of these has different requirements. And you need to understand when you're on each individual section, such as trench widening, do I need to do density testing, and how do I do that density testing? If I have a small quantity or I'm doing patching, how do I achieve the density that's required by the specifications? And those specification requirements are in that density specification. That's supplemental spec SS 315 asphalt concrete placement. And you have a copy of that in your specifications book. So here's that overview I'm talking about. Now we're going to talk about if you're doing a roller pattern control strip, you're going to use a nuclear gauge to do that. You're going to start out constructing a roller pattern. We'll talk about that in more detail. You'll go down and that specific roller pattern determines the number of passes that are required for that specific mix in that specific location using this very specific equipment that you have on site. That's why you have to do a roller pattern on each and every site when it changes, is because things change. So if you change equipment, you have to do another one. If you change the site to where the base structure changes, you have to do another roller pattern. Once those number of passes are determined, you'll go over and determine a control strip. That is actually setting your target. So you'll run 10 tests. We'll show you a little bit more about that in a minute. And you'll average those to get your target density for a specific mix again. So you've done your roller pattern, determine the number of passes. You might need to do 4 vibratory passes and 4 static passes or something along those lines. And then you get into the control strip and you ensure that you actually meet the requirements. You have to verify that that control strip average meets the requirements of the specifications. Once you've done that, you can start doing your test sections. Each test section is developed differently. I'll show you in a minute. There's 2 methods. There's a method A, there's a method B. And you can go through that and determine the average density for a test section. They're broken down into sub-lots and lots. And then you get the acceptance for that final lot. So if you pass all those, then you've met those specifications. And we're going to walk through this in an overview, and then again later we'll have individual modules that actually explain it even further. So now let's talk about some of those special considerations. You might have thin asphalt lifts or surface treatment roadways, or you may even have a structure that's weak and you're out there paving. And there are certain requirements for those that you need to understand that differ from a standard just overall paving operation. So things such as thin lift asphalts are defined as application rates that are 125 pounds per square yard or less. So if you're in that inch and a quarter or less range, 125 pounds, so if your contract says that you need to be placing 125 pounds, then that's considered thin asphalt lifts. And there are no direct density requirements. Things such as the asphalt over top of surface treatment. Surface treatment itself creates a unique challenge. It's difficult to get cores out of that surface treatment roadway so that you can't get the cores out of it and get an accurate measurement. And also many of the surface treatment roadways that we have are weak. And we'll talk about those weak structures because that's the next step. If you have a weak structure, there's a density table specifically for that, table 3-3. So if you can't meet your density requirements due to a weak structure, then you have to do that. And we'll talk about that further as well. So if you're doing density requirements, roller pattern, control strip, and test sections, like I talked about a minute ago, those are required for all paving operations where you have some sort of structure in place. So if I have a weak structure, I got to first determine that it is weak, right? So you want to make sure that you've truly got a weak structure. You've gone through your roller pattern, you've gone through a control strip, you're trying to get density, but you're unable to get that density. So in that case, if you determine that that is a weak structure, cores are not required for, again, for those thin lifts or for surface treatments. Same thing, if you got cores that are on a weak structure, you may have to take a core out of that weak structure to determine that you actually are establishing an actual density. So now you may determine that you got 95.3% in that specific instance. However, you determine that the structure itself is weak and you're unable to continue that. You'll continue to run nuclear density testing, and you'll run each test section nuclear density testing based off your targets, but you don't have to meet that minimum requirement if it's a weak structure. Final payment, it requires 98 to 102% of nuclear gauge testing. So once you actually go passing down the roadway, to get 100% pay, you need to be 98 to 102% using the nuclear density gauge. Now let's talk about small quantities, and specifically locations where a roller pattern control strip cannot be established. So those are typically 3,500 feet or less, but they're intended to be sections that are independent. So you may be out on a roadway and your contract requires you to just pave a turning lane, or it may require you to pave a section of roadway that's only 1,500 feet in length. Well, when you go through the process, and we'll talk about that later on, of what it requires to do a roller pattern control strip and then all your test sections, you'll see that it's very difficult, if not impossible, sometimes to actually go through all those steps when you only have a small quantity in paving. So what you'll do then is only use cores. And those cores are taken out of a section that's considered to be a small quantity. Again, it's typically 3,500 feet or less. And then you have a minimum density table, and that's table 3-5. I'll show you that table here in a minute. And through that, you're going to take one core or plug for the first 500 feet, and then you're going to take one core or plug for every 1,000 feet thereafter. So acceptance is purely based off of cores at that point, and those are compared back to your rights numbers, and we'll go through that step later on, so you'll fully understand how to follow that process. But again, for small quantities, typically 3,500 feet or less, you have a minimum density and you're using cores only. You're not using that roller pattern and control strip because you just don't have enough length to actually create that. And this is that table 3-5 I just spoke about. You'll actually compare those cores to this table, and you'll see that as long as you get 92.5 or greater, you're going to get 100% pay for that paving. However, if you go all the way down to the bottom, you'll see that if you get less than 88%, if you take a core and it's determined that it's less than 88% of maximum theoretical density, then now it's in removal. So now you have to do it again. So they have a pay table. You'll take those cores out. Again, you take one core in the first 500 feet, and you take another core every 1,000 feet thereafter. Those cores have to meet the requirements of this table, and that's how your pay is determined, or if it's severe enough and it's less than 88%, you'll actually have to remove it from the roadway. And that removal is at no cost to the department, so you get to do it again. So it's very critical that you ensure you get proper density, even if it's a small quantity paving operation. So let's talk about patching. Again, we talked about there's all these different nuances associated with density testing. Patching is one of those. Many times you'll have patching set up specifically on a contract. It might be prior to placing an overlay. It might be that you're just patching as part of that contract. But those patch requirements are very similar to small quantity because it's the same sort of thing. However, now you're specifically just talking about a patch. You may be on a roadway and that patch may only be 100 feet long. It may be 12 feet wide, but it may only be 8 feet wide or something like that. In that case, again, you're going to use cores to compare against that maximum theoretical. You don't have the ability, obviously, to set up a roller pattern and control strip, so you're going to use cores for this. And you're going to do, in this case, one plug or core for the first 20 tons. So now you're basing it off of tonnage as opposed to linear feet. So the first 20 tons, you're going to get a core, and then for every 100 tons thereafter, you're going to get another core. So you'll do one at the very beginning in the first 20 tons, and then for every 100 tons thereafter, you'll be getting a core. And that has to meet a minimum density of 91.5 of GMM. And once you do that, there's a pay table also for that, and that's table 3-6. And that's the table that you see here. Again, that determines your pay level and whether or not you have to get to that removal or replacement section, which is all the way down again at that 88%. So it's very similar to the other table for small quantity paving. As long as you get 91.5 in this case for the patching operations, it's recognized that small quantities like this, where you're dealing with very small patches, you need to meet that minimum 91.5 as opposed to the 92.5. However, again, if you're less than 88%, it's remove and replace at no cost to the department. So now let's get into what's considered really the bulk or the meat of what we do day in and day out, and that's that large quantity paving. That's the QC test sections and lots for each one of those. That's when you're sitting down with your paver and you're actually paving sometimes half a mile, sometimes 8 miles. And so now you're setting up for large quantity paving operations. In that case, we're going to go back to that roller pattern control strip, but the test sections and lots that are associated with large quantity paving, those are randomly selected test sites. So it has to be a stratified random. I'll talk to you in a minute about what that means, but it has to be stratified random. There's things such as where you have to test. So when you're running a nuclear gauge, you don't want to run a test that's within a foot of the longitudinal joint for surface and intermediate, and within 18 inches for base mixes. For that longitudinal joint testing, however, though, now you are specifically trying to test that longitudinal joint, and you need to be within 4 inches of that longitudinal joint for the surface and intermediate mixes, and you need to be within 6 inches for base mixes. Now, the lots themselves, you're going to test 2 tests per sublot. So now you're doing, again, you're doing your testing for a nuclear gauge. You're going to do 2 tests per sublot. A sublot is 1,000 feet. There are opportunities if you do a lot of paving in a given day, or if you're going to be doing a lot of paving, you can go to VDOT and say, hey, we're putting down 2,500 tons a day. I need to increase this so that I can reduce the amount of testing and still achieve what VDOT wants. And you can increase that up to 1,500 feet. But again, that has to be based on VDOT approval. You have to request that. You can't just change that on your own. Lot size can vary though. The overall lot size from 3,000 to 7,000 feet. A standard will be 5,000 feet, right smack in the middle of that. A standard lot is 5,000 feet, but it can range from 3,000 feet to 7,000 feet. That same rule applies now if you're talking about high quantities of paving that you're doing on a day-to-day basis. You can go to VDOT and say, I'd like to increase my lot size, and now you can potentially increase that from 4,500 feet all the way up to 10,500 feet for high production with VDOT approval. Always keep that in mind. You have to get that VDOT approval prior to actually making that change. Last thing, you're supposed to start a new lot at the beginning of each production shift where possible. So If you've, at the end of the production shift, that last lot ends at 3,000 feet, then you've got a full lot and you stop right there and you start a new lot the next day. And we're going to go through all this in more detail. So now for longitudinal joint testing. Those can be found in section 315.05E1B. We talked a minute ago about the locations for those longitudinal joint tests. Just like we said earlier, it has to be 4 inches off that joint for surface and intermediate bases. It has to be 6 inches for base mixes. So whereas before, your tests, for your test lot sections, you're actually trying to get away from the longitudinal joint. In this instance, you're trying to be right next to that longitudinal joint. And you're going to test each one of those as you go down the road. We'll talk about the details of how many tests are required in a minute. But you have to meet 95% of that target value. So now each one of those tests, as you take it, has to meet that 95% requirement. And if it doesn't, then corrective action is required if that density is not achieved. So now you have to tell somebody, okay, we've encountered now, I've got 2 tests in a row here that have failed, and we recognize, for example, that the roller's probably not hitting the longitudinal joint as well as it should be. It may have missed it a few times. We've talked to the roller operator, now we're back on track. We've got another test that's passed. That was our corrective action. We fixed our operation so that now we're achieving that longitudinal joint. But there's no pay adjustment for longitudinal joint testing. But you do have to record it, and anytime one fails, you have to go through that process of ensuring you have a corrective action in place. So let's talk about this longitudinal joint testing right now. So here's an example where you're out on a rural route. There's no paved shoulders on this route whatsoever. So what do you have? You only have 1 longitudinal joint. But you will have longitudinal joint tests, of course, for each lane that's paved. So the first lane that's paved, you're going to have to do a test. That's going to be unconfined because you haven't placed the one adjacent to it if it's an overlay. So now you've got an unconfined test, and then you're going to come back, place the other lane, and now you're going to have another test. So in this case, it's a rural route. You only have 2 longitudinal joint tests because you really only have 1 longitudinal joint in this instance. So now let's look at one that's a divided or sometimes an undivided road with just a narrow shoulder. You'll see in the slide that you've actually got a slight shoulder on the side that's only a few feet at most. And that one, they're going to pave that lane all in one paving operation. So you don't have a joint over there next to that shoulder. Again, in this instance, because of that fact, you're only going to have 2 longitudinal joint tests. You're going to have 1 for each lane against that center line longitudinal joint. So in this instance, again, you only have 1 longitudinal joint, so you only have those 2 tests that are required for longitudinal joint testing. Now let's look at one that has a full shoulder. So in this instance, you'll see that you actually have a full shoulder on your travel lane, but over on the opposite side, on the passing lane, you have a very narrow shoulder that, again, that one will be paved with that operation. So now in this instance, you have 2 longitudinal joints. You'll have your standard longitudinal joint in the middle between the 2 lanes. You'll have 2 tests for those longitudinal joints, and then you'll actually have to have another longitudinal joint test over on the travel lane against that shoulder, because now you have another longitudinal joint that's adjacent to that. So now you'll have 3 longitudinal joints where you have a full width shoulder that you're paving with. And then that goes all the way up to, say, a full interstate system where now in this case we have 4 lanes and we have full shoulders on both sides. And so now you're actually doing longitudinal joint tests for each and every one of those longitudinal joints. So if we work from the outside to the inside, we have a shoulder, we have a full shoulder in this instance. We're actually going to do a longitudinal joint test right there in that first travel lane. One thing you'll recognize, you're not doing longitudinal joint testing on the shoulder side. That's a different acceptance process. So now, for longitudinal joint testing, you're only doing it for the main line paving. So there'll be a longitudinal joint test on the main line right there at that shoulder joint. Then you'll see there's another one for each one of the actual center line longitudinal joints between each lane. And then again, you have to do one over on your opposite side that's on the inside shoulder. You'll have a longitudinal joint test on that inside shoulder as well. So in this instance, we've got how many tests we got? 1, 2, 3, 4, 5, 6, 7, 8. So we had 4 lanes with shoulders. So now we have 8 longitudinal joint tests. So now, what if you have curb and gutter? So I've got a section of roadway out there where I've got a curb and gutter, a concrete curb and gutter. I'm paving in a town or a city or a subdivision. What do? Do I set that gauge down there and I run a test against that curb and gutter? No. If you actually have a concrete curb and gutter section, you are not required to perform a longitudinal joint test because we don't want to damage that gutter pan. So the intent here is to ensure that the paving operation and the roller operation pinches that joint down as best they possibly can right at that gutter pan, but you are not required to meet the longitudinal joint spec when you have a curb and gutter section. So now let's talk about trench widening. We've talked about a number of different unique situations that occur outside of the normal operations of paving. Trench widening is one of those. And VDOT has a specific supplemental spec for trench widening, and that's 321.05. It talks about all the acceptance requirements for trench widening, and specific to density testing, it tells you that you need 1 core for the first 500 linear feet, and then you need another core for every 2,500 linear feet thereafter. However, there is an exception to that. There are 3 different types of trench widening. So for type 1 trench widening, and type 1 trench widening is completely outside of your standard roadway. So the trench widening, such as you see in the picture down below, is outside that white line. So if it's type 1 and it's completely outside the travel way, there's no minimum density required for those. And it specifically tells you that you need to do a minimum of 5 passes with at least a minimum of 8-ton roller. So you don't do density testing for type 1 trench widening. However, you do for the other 2. For type 2 or type 3 trench widening, there's a minimum density of 91.5%. And you'll do that for each one of those because both of those are actually extend into the travel way. So it depends on what type of trench widening you're doing as to depend on what types of requirements are necessary. Again, type 1, you don't have to do any density testing, but type 2 and type 3, you do. So now let's talk about standard paving operations again. There are 2 different ways that we do that. There's a method A and there's a method B. First, let's talk about method A. And that one is where we're testing purely based off of, accepting purely based off of the method A cores or plugs. So we're not using nuclear density for acceptance. I'll talk a minute about using the nuclear gauge for quality control, and for longitudinal joints, but for acceptance, we're using cores. And that's for anything that's a traffic group 10 or higher. So therefore it has to be 2,000 vehicles, greater than 2,000 vehicles a day for you to use method A. And that's usually outlined in your contracts. It also has to have a minimum of 20 feet in width. So the pavement can't be less than 20 feet. If it's an 18-foot roadway, you can't use method A testing. It has to be a minimum of 20. It follows that same VTM 76 we talked about at the very beginning for roller pattern and control strips, but those test sections and the results of those are based on table 3-4A, and we'll talk about that and I'll show you that in just a minute. You also have to compare those against the average daily RICE, or therefore the GMM value. So now each day you're testing for these cores, you're comparing that back to the maximum theoretical density, your GMM, and it's based off of a average daily RICE. And here's that table that I just talked about, table 3-4A. So if you look at all those, it talks specifically about method A densities for whether it be surface, intermediate, or base. And if you're greater than 96.5, you'll see that you actually have a deduct. Now, there's a change to that. If you look at the note down below, for base mixes only, that actually increases up to 97% of maximum theoretical. So for surface and intermediate, if it's greater than 96.5, you actually have a 5% penalty. Your target value for 100% pay is 92.5 to 96.5. That's 100% pay. And just like we talked about earlier, in some of the other tables, you'll see that if you have less than 88%, that it's actually remove and replace. And again, that is at no cost to the department. So keep in mind that this pay lot table, this is for method A, and that details out what your pay would be for each density level that you may achieve on your roadway. There is a bonus for density for method A type density cores and plugs. So keep in mind that if you have at least a minimum of 80% of all your sublots, cores and plugs, that are no lower than 92.5 for maximum theoretical, then you have the opportunity now to get a 5% bonus. So the lot average results has to still meet 100%. So all 5, let's say you had 5 tests, 4 of them met the requirement of 92.5, but all 5, when averaged, have to meet that 100% pay requirement. If that occurs, then you can get up to a 5% pay adjustment. So now let's talk a little bit about method B. Method B is that nuclear gauge density testing. You started out doing your roller pattern and control strip using a nuclear gauge to determine the number of passes and determine your target values. For routes that are traffic group 9 or less than 2,000 vehicles a day, you're going to use method B, and that is again that nuclear gauge testing. So now it does not have that requirement for that 20-foot width. So again, for method A, where you're using cores, it has to be a minimum of 20 foot in width. For method B, it doesn't matter the width. You'll still use method B testing even if it's less than 20 feet. And it follows that same VTM 76 for that roller pattern and control strip, like I said. So now this is the method B pay table we talked about. This is table 3-4B, and this is how you determine pay for that method B nuclear density testing that we just talked about. We'll go through this in much more detail later on. However, this table details out specifically how the pay is occurring for different density levels using method B, nuclear gauge. So if you're greater than 102%, you'll see that there's actually a deduct. You'll have a 5% deduct. However, to get 100% pay, you're in that 98 to 102% range. So if you want 100% pay, you need to be 98 to 102% of your control strip density. So for method B now, we're comparing back to that control strip target as opposed to maximum theoretical or your GMM. We're using the control strip target. So 98 to 102% gives you 100% pay. However, if you follow that chart all the way down, you'll see at the bottom levels, less than 96%, you're actually in that remove and replace level. So now again, where you don't want to be is if you get down to the lower level of density on a specific route, even for method B, you're in removal and replacement, and that's purely at no cost to the department. This has just been an overview of all the density testing and density testing requirements, taking you from the roller pattern and control strip, talking about different types of unique situations for density testing, and then your method A and method B requirements for test section. We're going to walk you through each step of those from the subsequent modules. If you have any questions, please see your moderator.